Business Mathematics, Chapter 2, Mathematical Application in Finance. So the chapter covered in this subtopic is compound interest, which is introduction to compound interest and compound interest formula. Previous topic, we have studied about the simple interest, but almost of the banks never charge by using the simple interest to their customer. They prefer to use compound interest. Why they every bank prefer to use compound interest? So let me look at here. Okay, the bank say if you paid me everything back after 1 year and then I loan it to you again, it will be loan you 1,100 for the second year. So I want more interest. So this sentence means that bank want to get more interest if they use the compound interest. This is the example how the compound interest works. Okay, let's say today Alex borrow 1,000 from the bank and Alex needs to pay 1,100 interest in the second year, not just 1,000. Okay, because Alex is paying 10% of 1,100, not just 1,000. Okay, so can you imagine lend the money to Alex after a year? You think that Alex owes me 1,100 now and is still using my money. I should get more the interest. So that's why bank prefer to use the compound interest. And so this is the normal way of calculating interest. It is called compounding. So with the compounding, we work out the interest for the period first period, add it the total, and then we calculate the interest for the next period and so on. So this is the example how the compound interest works. Okay, so for example, the first one, let's borrow 1,000 from the bank, and then the interest is equal to PRT, which is P is the 1,000 principal original value here. R is 10%, T is 1 year. So after 1 year, the interest earned is 1,100. Okay, so from 0 years, loan at the end for the 0 years is 1,100. Okay, so the principal at the first year is come from the calculate from the value or accumulate amount at the end of the 0 year. So it's become like this. Okay, loan at the end go to the loan at the first. So it's become 1,000 original principal plus with the interest earned. And then we will get the principal at the first year is 1,100. So how to calculate the interest for the first year is 1,100 is our new principal multiplied by the interest rate is 10%. Then we will get the interest earned is 110. Okay, so loan at the end of accumulate amount that Alex need to pay for the first year is 1,100 loan which is started plus with the interest earned. Then at the end of the first year, the loan is 1,210. And for the second year, loan accumulate at the end of the first year will become the principal for the second year. So 1,210 is the principal value for the second year, and the interest earned is 1,210 multiplied by 10%, so it will get 121. So loan at the end of the second year is interest earned plus with the loan at start, and we will get loan accumulate a loan at the end of the second year is 1,331. So this step is follow the sequence year by year. Okay, loan at the end will become the principal for the next year. Okay, at the end, okay, so the loan that Alex needs to pay for the end of the second of the 5 year is 1,610.51. Example 1. Alex borrow 2,000 for 2 years at 5% compound interest rate. How much the interest rate is? Okay, so we know here the interest rate for the first year is 5% from 2,000. So it's like 0.05. When we convert decimal place to percentage, 0.05 times 2,000. So the interest for the first year is 100. So at the end of the first year, he owed 2,000 plus 100. So it's become 2,100. So interest for the second year, 5% from 2,100. So it's become 0.05 times 2,100. Then the interest for the second year is 1,105. So the total amount of the compound interest is 100 plus with 105. So the total amount is 205, which is B. Example 2. Alice borrow 4,000 for 3 years at 10% compound interest rate. How much the interest is that? Okay, we have two methods here. For the first method, how to find the interest for the first year? Interest for the first year is 10% from 4,000. We calculate, then we will get 0.1 multiplied by 4,000, then we will get 400. So at the end of the first year, she owes 4,000 plus with 400, then it will give us 4,400. So interest for the second year is 10% from the 4,400. So it will get 0.1 times 4,400. So it's become 440 for the interest for second year. So at the end of the second year, Alice owes 4,400 plus 440, which is 4,840. So the interest for the third year is 10% from the 4,840, which is 0.1 multiplied by 4,840, which is 484. So the total amount of compound interest for the whole year is, we need to plus all the interest earned that we get from the first until end, which is 400 plus with 440 plus with 484. Then the total compound interest is 1,324. The second method is we use the formula to find the compound interest is face value equal to present value multiplied by 1 plus r to the power of n. Okay, so our present value is the amount that Alice borrowed here, which is 4,000. Then the simple interest rate or interest rate is 10%. So we change to decimal place, which is 0.1, and the year is 3. So FV, by using the formula FV equal to PV times 1 plus R to the power of n, we just substitute all the value that we have get in the equation, which is present value 4,000, we already have. Then we have also the interest rate 0.1, and we also have n equal to 3. Then we calculate all of these, then we will get the face value is equal to 5,324, which is the answer for this example. Is we need to find the interest earned. So the interest earned is face value minus with the present value. Then we will get the answer is D, RM 1,324. Example 3. Simon borrowed 1,000 for 3 years at 5% compound interest. So how much did he owe after 3 years? So for the first method, we calculate the interest for each year. Interest for the first year is 5% from 1,000. So it will be 0.05 times 1,000. We will get 50 ringgit. So at the end of the first year, she owes 1,000 plus with the 50 ringgit, then we will get 1,050. So interest for the second year is 5% from 1,050. So we will get 0.05 multiplied by 1,050, then we will get 52 ringgit and 50 cents. So at the end of the second year, she owes 1,102 ringgit 50 cents. So interest for the third year is 5% from the 1,102 ringgit 50 cents. So we calculate 0.05 multiplied by 1,102 ringgit 50 cents. Then we will get 55 ringgit and 30 cents. So the total amount of interest, compound interest, is 1,102 ringgit and 50 cents plus with 55 ringgit and 30 cents. So the total amount is D, is C. Okay, 1,157 ringgit and 63 cents. So method 2 we will use here is FV equal to PV times 1 plus R to the power of N. So our present value is given here is 1,000 because the word borrow here, borrow means the present value. Okay, so we also are given the interest rate 5%, so we convert to decimal place 0.05, and year is T, which is N equal to 3. And we calculate, we get FV equal to 1,000 multiplied by 1 plus 0.05 to the power of 3. And then we calculate this, we will get the same answer like the method 1, which is 1,157.63. Example 4. 2,000 is invested for 3 years. Find the interest earned if the interest rate is, okay, the first one, 8% per annum simple interest. Okay, so if you use the simple interest, so our principal didn't change here. So every year the principal is 2,000. So the interest earned also didn't change here because we calculate the interest equal to PRT, and our principal, our interest rate is same for every single year. So the accumulated amount at the end of the third year by using the simple interest with the interest rate 8% is 2,480 ringgit. Okay, so therefore the simple interest earned is 3 times 160 ringgit, which is equal to RM 480 ringgit. So method 2, instead of we using this table, we also can use the formula of interest earned, which is equal to PRT. Then we just substitute the value of P 2,000 multiplied by 0.08 multiplied by 3. Then we will get the interest earned equal to 480 ringgit. Example 5, 2,000 in invest for 3 years. So find interest earned if the interest rate is 8% compound annually. So if we come up with this table, so the principal for every year is different here because the principal for the second year comes from the accumulated amount at the first year. Okay, and the principal at the first third year comes from the accumulated amount at the end of the second year. Then if you look at this table, the interest earned also different for each year because the interest earned change because our principal is changed for every year. The principal for every year depends on the end value at the end of accumulated amount for every single year. So if you look at this table, the accumulated amount at the end of the third year, we will get 2,550 ringgit point 42 cents. So the simple interest earned is we total up all the interest earned from the first year until the third year, then we will get 550 ringgit 42 cent. So the simple interest calculate based on the original principal, while the compound interest calculate based on charge of principal for each year. There are two different between simple interest and compound interest. Okay? If we look at both example, okay, even though we are use the same um, interest rate, the same year, the same principal at the first of year, but they will give us accumulate amount at the end of the third year is different. It look like the compound interest is greater. It is greater than the accumulate amount at the end of the third year by using the simple interest. That's why many of bank we use the formula by using compound interest to their customer in order to get more profit when they charge their customer by give them a loan or some deposit. This is the important term that we need to know in compound interest. The first one is P. Okay, P is the original principal, or we also know it as face value FV. Frequency of conversion M. Conversion period, interest period, compound annually, compound semi-annually, compound quarterly, compound monthly, compound every 2 months, and also compound for every 4 months. The example 6. 1,000 is invested at 5% compound semi-annually for 2 years and 6 months. So we want to find the original principal here. So the original principal is equal to P equal to 1,000. So B, annual interest rate. Annual interest rate is K equal to 5%. Okay, C, we want to find the interest period. So interest period is 6 months because we compound semi-annually. So every semi-annually means we have 6 months. Okay, frequency of conversion M. Km equal to 2 because semi-annually here. So interest rate per interest period. Okay, so the formula for interest rate for interest period is I equal to K over M. So our K is 0.05 divided by the conversion frequency 2. Then we will get 2.5%. Number of interest period in the investment period. So the formula for the number of interest period is N equal to Tm. So the T is 2 years 6 months. We convert to mixed proper fraction. Okay, so we will get 30 over 12 multiplied by M. Conversion frequency is 2. Then we will get our N is equal to 5 here. Example 7. Find the future value for 2,000 invest for 3 years at 8% compound annually. So in this question, we want to find FV, future value. So we are given present value, which is 2,000. So we will use the formula S equal to P 1 plus I to the power of N. So just plug in the information given to us. Our present value is 2,000. The formula for I is equal to K over M. So our K is 8%, 0.08. Then our M is 1 because compound annually. So N is equal to MT. So M is 1 multiplied by T equal to 3. Then we will get the future value for the first question is 2,550 ringgit 42 cent. Okay, for the second question, we want to find the future value for the 5 years 6 months by using 4% compound semi-annually. So we will use the same formula, but the difference here is I equal to K over M. So K is 0.04 over M equal to 2 and our N equal to MT. So M times T, then we will get 11 here. So we will get the future value for this question is 2,486 ringgit 75 cent. Okay, the third question, we want to find the future value for 2 years, 3 months at 8% compound quarterly. So the same formula we will use, but the difference here is our K over M. K over M is equal to 4 now because compound quarterly. And our N also different because the value of M is 3 and T is 2 years 3 months. Then we will get 9 here. So the future value for the C, question C is 2,390 ringgit point 19 cent. So for D, we want to find the future value for 4 years 6 months at 12% compound monthly. So what is the difference here between the equation above is the value of interest rate. Okay, the value for M also different because compound monthly. So compound monthly means M equal to 12. So our NT also different because T is 4 years 6 months. We need to convert to years. Then times with 12 here. Then we will get the future value for this question is 3,422 ringgit and 82 cents. For question E, 2 years 8 months at 6% compound every 2 months. So the difference here is T 2 years 8 months, K 6%, M equal to 2 months. So when we just plug in all the information given to us, we will get the value of I equal to 0.06 divided by N because we compound 2 months every 2 months. So 12 divided by 2, we will get 6 here. So our N equal to MT. So M is equal to 6 multiplied by T 2 years 8 months. Then we will get the future value is 2,345 ringgit 15 cent. Okay, so for F, we have 5 years at 9% compounded every 4 months. So the P value is same 2000. Okay, the interest rate is 0.09. So M equal to 3 because 12 divided by 4, we will get 3 here. Then our T is 3 times with 5, then we will get 15 here. So the future value for F is 3,115 ringgit and 93 cents. Example 9. Girls invest 20,000 in an account for 5 years. The investment account pays 12% compound semi-annually for the first 2 periods and 15% compound every 4 months for the rest of the period. So if we draw the timeline, so it becomes like that. Okay, for the first 2 years, okay, for the first 2 years, there are 4 interest periods here. Okay, which is the I is equal to K over M. So our K for the first 2 years is 12%. Compound semi-annually. Semi-annually, our N M equal to 2. So our I will become 12% divided by 2. We will get 0.06 here. Okay, so N is equal to MT. So our M is equal to 2. T is 2 years. Then we will get N is equal to 4. Okay, for the second years until the 5 years, for the value of K is 15%, compound every 4 months. So compound every 4 months mean our M is equal to 3. Okay, 12 divided by 4, then we will get 3 here. So the value of I for the rest of 2 years ahead is 15% divided by 3. Then we will get our I is equal to 0.05. Then our N is equal to MT. M equal to 3 times with T 3. Okay, 5 minus 2 years. Then we will get 3 here. Then the value for N is equal to 9. Okay, so the first question, we want to find the maturity value of her investment. Okay, so accumulate amount after 2 years, okay, that we calculate for the S1 first. Okay, S1 from year 0 to year 2 and accumulate amount from year 2 until year 5. We need to calculate separately because they are the different between the value for I and also N. Okay, so for the first S1 is equal to P times 1 plus I power of N. So our P is 2000 times 1 plus 0.06 is I that we have calculated previously. Okay, N is equal to 4. Then we solve for it, we will get our S1 is equal to 25,249 ringgit 54 cent. Okay. Then we count for the year 2 until year 5. Okay, but our P starting at year 2 we take from our S1. Okay, so our P now becomes 25,249 ringgit 54 cent because this is the compound interest. So the principal value will take from the end of the second year. And we multiply by 1 plus I. So our I that we have get previously, which is 0.05, then close the bracket, power of 9. Okay, we also calculate the amount of N previously. Then we calculate here, then we will get our S2 is equal to 39,170 ringgit 32 cent. Okay, so that is the maturity value for her investment, which is 39,170 ringgit 32 cent. For number B, we want to find the interest earned from this investment. Okay, so if we look at our S2, which is the accumulated amount at the end of the first 5 years that we have get previously, we need to minus with the principal. Okay, principal at the first or 0 year starting we invest. Okay, so that we will get the amount for compound interest earned here. So then when we minus 39,170 ringgit 32 cent minus 20,000, then we will get the compound interest earned here is 19,170 ringgit and 32 cent. Example 10. Zakia saved 3,000 now and another 1,000 after 3 years in an account paying 12% compound quarterly. So find the amount at the total interest in the account at the end of 5 years from now. So if we can summarize from this question, we come up with this timeline first. So our P1, okay, principal for the 0 years starting at 3,000 here. Okay, why? After 3 years, Zakia add the saving 1,000. Okay, so that is the information given to us. Then the interest rate is 12% compound quarterly. So our N is equal to MT or TM. Then our T is 5 multiplied by 4 because compound quarterly. And find the amount of total interest in the account. So we want to find our S at 5 years. Okay, so how to do it? Okay, our I is equal to K over M. So K is interest rate 12% over M4, then we will get our I is equal to 0.03. Okay, our S is by calculate S1 first. Okay, S1 starting from year 0 until your year 3, and our S2 is starting from year 3 until year 5. So we just plug in the formula here. So for our P1 we have 3,000 times with 1 plus 0.03. Okay, 0.03 that we have calculated above, which is I equal to K over M, power of 20. Okay, 20 because from 0 to 5. Okay, we calculate from 0 year to 5 year here. Okay, then plus with P2. Okay, so P2 is for the adding saving 1000 at the third year here. So times with 1 plus 0.03 to the power of 8. Why 8 here? Because from times year 3 until year 5, we will get n equal to mt. So our m is equal to 4 multiplied by t2, then we will get 8 here. Okay, so we plus both answer, then we will get the total accumulated amount at the end of the 5 year is 6,685 ringgit and 10 cents. Okay, so interest earned for the 0 until 5 year is we need to minus accumulated amount at the end of the 5 years with 3,000. Then also we need to minus 1,000 that the Zakia saved at the third year. Then the total interest earned we will get here is 2,685 ringgit 10 cents. Example 11. If 1,000 will accumulate to 5,054 ringgit 47 cent in 17 years, so what is the interest rate compound annually? So we have our n here, n equal to mt. So since this is compound annually, so our m is equal to 1 multiply year 17, then we will get the n equal to 17. Okay, so let me find the value of k because we want to find the interest of rate. Okay, so we have the formula for compound interest, which is S equal to P times 1 plus I to the power of N. So we already given in the question the amount of accumulated amount here, which is 5,044 ringgit, 54 ringgit and 47 cent. While our principal or original value is 1,000 multiplied by 1 plus k that we want to calculate here over I. So I is compound annually, so I is equal to 1 here. Power of 17. Okay. So we solve for this question, then we will get the amount of k is equal to 0.1. Since k is interest rate, so at the end of your answer, you need to convert to percentage. So we will get the amount of k is equal to 10%. Example 12. A certain sum of money was invested at 8% compound annually. How long it will take to double in value? So first of all, we write down the formula for compound interest first. So if you look at this question, sum of money invest, then the amount of principal will double at the end of the saving, okay, at the end of the investment. So let we assume our P principal amount is X, then we declare that our accumulated amount is double from principal, then we take 2X here. Okay, so why our I equal to K over M, which is K equal to 8% over M, M compound annually, so M equal to 1 power of T here. So we divide to X divided by X because there are multiplication here. So when we want to solve for it, we need to divide. So what happened after we divide? We will get 2 equal to 1.08 to the power of T. So we want to find the amount of year here, how long. We want to find the value of year. So we need to put T in front of 1.08. So in order to put T in front, so we need to add log for both equation right and left hand side. So we just multiply T with log 1.08. Then we will get T is equal to log 2 divided by log 1.08. So we just press the calculator, then we will get T equal to 9 years. So this is the graph for present value. If you look at here, the year versus learn versus year. So if we look here, it grows faster and faster if we count the amount for present value. Okay, so what is present value? Okay, here are the calculation for 5 years at 10% interest rate. So that we have at 0 years we have starting the loan at 1,000 with the interest of 10%. Then we will get the interest earned at the end of the 0 year is 100. So loan at the end of the 0 year is 1,100. Okay. So loan starting for the first year, we will take our accumulate amount at the end of 0 year. It will become the principal, the loan at the first year. Then we calculate the interest earned, we will get 1,110 here by using the formula I equal to PRT. Then loan at the end of the first year, we will get by adding the loan as the starting plus with the interest 110, then we will get the loan at the end of the first year is 1,210. Okay, so we repeat the same methods here. Okay, we bring loan at the end of the first year. Okay, will become the value for principal at the loan at the first second year. Okay, then we calculate the interest earned by using I equal to PRT. Then we will get the loan at the end of the second year by adding loan at the first year principal plus with interest. Okay, so we repeat every step until year 5. Then we will get loan at the first year at year 5 is 1,610 ringgit and 51 cents. So if you use that formula, it looks like very long way to solve if we have saving or invest for the long term period like 10 years, 20 years. So how come we calculate by table like that one by one until 100 years? Okay, so we need to solve this problem by using some formula in order to make that easy. Compare then we use the table to solve that formula. So how to make a formula that we look at these notes. Okay, so let us make a formula for the above, just looking at the first year to begin with. Okay, first year 1,000, we have plus 1,000, okay, which is 1,000 here is P plus PRT plus I, means okay, we want to find the amount of S here. So S equal to P plus I, then we will get at the end of the 0 year, our S is 1,100. Okay, so we can rearrange like this. So loan starting at 1,000 with the interest earned is 1,000 times 10%. Okay, so the second step, if we change the percentage to decimal place, then we will get 10% is equal to 0.1. Then we factorize this one. Okay, if we want to factorize, then it will become 1,000 multiplied by 1. Okay, so 1,000 multiplied by 1 plus 0.1, then we will get 1,000 times 1.1. So we just add in 10% interest in the same by multiplying 1.1. Continue with the subtopic present value. So interest rate was turned into a decimal by divide by 100. So how to change 10% to decimal place? So we just divide 10 by 100, then we will get 0.1 here. Okay, so read the percentage to learn more, but in practice just move the decimal point like this. Okay, so if we have 10%, so we want to convert to decimal place, we just move the point at the end to the back 1 and 2 times, because 100 have 2 digits of 0. So that's why we get 10% equal to 0.1, 12% equal to 0.12, and 6% we convert move to, then we will get 0.06 here. Example 13. A certain sum of money was invested at 7% compound quarterly. So this investment will be worth 50,000 at the end of the 6th year. So find the original principal. So we know here our M is equal to 4 because compound quarterly. So we have 6 years, so N will become 4 times 2, which is 24. Okay, so our S formula compound interest for accumulated amount S equal to P 1 plus I to the power of N. But we want to find the original principal here, means we want to find the value of P. So P is equal to S over 1 plus I power of N, or P equal to S multiplied by 1 plus I to the power of negative N. So we just plug in all the information given to us, which is S equal to 15,000. Okay, our I is equal to K over M. K equal to 0.07 divided by 4 because M is compound quarterly. Okay, power of negative 24. Then we will get the original principal here, which is equal to 9,891 ringgit and 57 cents. Example 14. A house is estimated to cost 120,000 in 10 years' time. If you so wish to buy this house in 10 years' time, how much must he deposit now in an account that pays 10% compound quarterly? So we have our N equal to MT, which is M compound quarterly, M equal to 4 multiplied by T equal to 10, we will get N equal to 40. So formula for S equal to P 1 plus I power of N. So we want to find the amount of deposit. So amount of deposit means the amount of P, original principal. So we use the formula for present value. Then we just plug in the information given to us, which is we already have the amount of accumulated amount. Okay, which is 120,000 multiplied by 1 plus 0.01, our K over M, 4 because compound quarterly to the power of negative N, negative 40. Then we will get the compound, we will get the deposit now, or original principal is equal to 44,691 ringgit and 67 cents. It's like if we want to buy this house, so we need to have the deposit now 44 ringgit 691 ringgit and 67 cents. Example 15. A debt of RM 8,760 will mature at the end of the second year. So if the money is worth 12% compounds monthly, find the value of this debt now. Okay, so now means we want to find the value of P, which is the present value. So P is equal to S times 1 plus I to the power of negative N. So our S now is 8,760 ringgit because this is the N value at the end of second year. So our K is 0.12, our M is 12 because compound monthly, power of negative N. So N is equal to 24 since compound monthly M equal to 12 multiplied by 2 years, then we will get N equal to 24. Then we will get the amount of present value now is 6,899 ringgit and 8 cents. Okay, B, at the end of the first year. Okay, so we want to find the amount of P at the end of the first year. Okay, because this question involves 2 years. So we want to find the present value at the end of the first year. Okay, so our T is equal to 1 now. Our M is still 12 because we compound it monthly. So we will use the same formula, which is P equal to S times 1 plus I to the power of negative N. So our S is same, which is 8,760. The difference between the first question only is our N because the year is 1 now. So we just substitute all the information that we have. then we will get the present value at the end of the first year is 7,774 ringgit and 6 cents. See, for question C, we want to find the debt value at the end of the fifth year. So if you look at this diagram or this number line, okay, from 0 to 2 year, end value is 8,760 ringgit. So at the end of the fifth year, okay, means from year 2 until year 5. So the end is equal to 12 multiplied by 3. 12 compound monthly multiplied by year is equal to 3. So we will get n equal to 36 now. So our accumulated amount at the end of the 2 year will become our principal for this value now. So we want to find the value at the end of the fifth year is we want to find the amount of S. So we just substitute into the compound formula for S, which is equal to P times 1 plus I to the power of n. But for this question, our S as we used in previous question will become our principal now because we take the amount of the second year will become our principal, which is 8,760 times 1 plus k 0.12 over 12 to the power of 36. Then we will get the amount at the end of the first year is equal to 12,533 ringgit and 53 cents. Example 16. Ismail invests on an amount of money to pay 10% payment on an apartment that costs 103,700 ringgit. So how much should he invest for 5 years at 7.5% compound semi-annually to get the down payment? So down payment is 10% from the total cost. Okay, so we will get the down payment is 10,370 ringgit. So our S now is 10,370 ringgit. So our I is equal to 0.075 over 2. And our N is equal to 5 year 5 multiplied by semi-annually M equal to 2. Then we will get N is equal to 10. So we want to find the amount of P. Okay, so P is equal to S multiplied by 1 plus I to the power of negative 1. Okay, so our down payment is S because we want that down payment after 5 years. Okay, so which is 10,370 ringgit. Multiplied by 1 plus 0.075, our K divided by M2 and to the power of negative 10. So that we will get our P is equal 7,176 ringgit and 25 cents. Compound interest formula. Example 17. If the present value of my investment is 1,000 and the rate of interest is 10% compound annually, so what will the value be after 6 years? So by using the formula of S equal to P times 1 plus I to the power of N, so we just substitute all the information that we have here, which is P equal to 1,000 times 1 plus our I is equal to 0.1 because it's compound annually to the power of n. So that we will get the value after 6 years. S is equal to 1,771 ringgit and 56 cents. So the answer is B. Example 18. If the present value of my investment is 1,000 and the rate of interest is 6% compound annually, so what will the value be after 10 years? So by using the formula of S equal to P times 1 plus I to the power of N, so we just substitute and plug in all the information that we have, which is P equal to 1,000 times 1 plus 0.1, which is our I. K is 0.06 over M is 1 because we compound annually. Power of 10. So that we will get the amount of the 10 years is equal to 1,790 ringgit and 85 cent, which is C. Example 19. With the present value of my investment is 2,500 and the rate of interest is 2%, compound annually, what will the value be after 15 years? So by using the formula of S equal to P times 1 plus I to the power of N, so we just substitute all the information that we have, which is P equal to 2,500 times with 1.02 to the power of 15. So that we will get our value after 15 years is 3,364 ringgit and 67 cent, which is C. Example 20. With the present value of my investment is 9,000 and the rate of interest is 3.5% compound annually. So what will the value be after 4 years? So by using the formula of S equal to P times 1 plus I to the power of N, so we plug in all the information that we have, which is S equal to 9,000 times 1.035 to the power of 4. So that we will get the value after 4 years is 10,327 ringgit 71 cent, which is D. Example 21. Your goal is to have 2,000 in 6 years. The rate of interest is 10% compound annually. So how much should you start with? So by rearrange the original formula, then we will get our present value is equal to S over 1 plus I to the power of N. So we already given our S is equal to 2,000. So we will get P is equal to 2,000 over 1 plus 0.1 to the power of N. So how much we need to start, which is original principal, then we will get 1,128 ringgit 95 cent, which is D. Example 22. Your goal is to have 3,500 in 10 years. So the rate of interest is 3% compound annually. So how much should you start with? By using the formula of P equal to S over 1 plus I to the power of N. So we substitute the amount of S equal to 3,000 over 1.03 to the power of 10. So that we will get the value of P is 2,604.33 ringgit. So our answer is C. Example 23. You have 1,000 and want it to grow to 2,000 in 4 years. What compound interest rate do you need? So original formula is S equal to P times 1 plus I to the power of N. So that we will get our I is equal to S over P power of 1 over N minus 1, because we want to find the amount of compound interest here. So we just substitute our S, P, and N. Then we will get our I is equal to 2,000 over 1,000 power of 1 over 4 minus 1. And therefore, we will get I equal to 18.92%. Example 24. You have 2,500 and want it to grow to 4,000 in 10 years. So what is the compound interest you need? So we rearrange the original formula and we will get I equal to S over P to the power of 1 over N minus 1. So we just substitute all the information of we have, then we will get I equal to 4,000 over 2,000 to the power of 1 over 10 minus 1. We solve for it, then we will get I equal to 4.81%. Example 25. So how many years will it take to turn 1,000 into 1,500 at 8% compound interest? So our original formula is S equal to P times 1 plus I to the power of N. So we rearrange this formula, then we will get N equal to log S over P over log 1 plus I. So that we will substitute all the information that we have in the equation, then we will get n is equal to log 1500 over 1000 over log 1.08. Then we solve for it, we calculate by using the calculator, and we will get n is equal to 5.268 years. So the answer is C. Example 26. How many years will it take to turn 2,500 into 3,000 at 3.5% interest compound annually? So find from the original formula S equal to P times 1 plus I to the power of n. So we rearrange the formula, then we will get n is equal to log S over P over log 1 plus I. So we plug in all the information that we have in the question. So we will get n equal to log 3000 over 2500. And then we solve for it, we will get n is equal to 5.3 years, which is the answer is B. With that, thank you.